Go ahead and okay, we've started the recording now of this session. We'll be talking about OSHA confined spaces, and this is Bill Spun with TruTech Tools. If you're not familiar with the company, we carry a lot of different products in many different areas. Some of our more recent additions are for the home products with indoor air quality and healthy home related safety products, especially those with regarding to the OSHA rule, Occupational Safety and Health Administration. As well as combustion testing, we do calibration, airflow measurements, and test and balance. We'll be providing this information about the physical and the atmospheric and physical temperature hazards in confined spaces as an educational resource for individuals. We're not responsible for the interpretation of the confined space rule. We'll be giving you some links where you can contact the OSHA office nearest you for guidance or interpretation, and also some links to some various articles on this topic. So we'll cover four main things today. What is the confined space rule and how could it pertain to the work you do? What test tools might you need in addition to those you already have? Can you use the tools you already have to comply with this rule if you need to comply? And how does the new BPI 1200 rule relate to the topic of confined spaces in OSHA? So dating back to well over a year ago, there was a new amendment to the Occupational Safety and Health Administration construction standard that went into effect actually August 3rd, 2015. It extended the notion or the concept of confined spaces to attics and crawl spaces amongst other spaces. So up to then it pretty much was related to industry and the construction standard has now enveloped attics and crawl spaces. The enforcement of the standard was delayed until March of 2016 if good faith efforts were being made because it was a new rule on a new group of individuals that would be working in this area. So they wanted to make sure everybody had a chance to accommodate and get in alignment with it. There's an article that was written where the ACCA, the Air Conditioning Contractors of America, worked to dialogue with the OSHA to determine how the standard would affect heating and air conditioning contractors and contractors and technicians is a very broad group. So this link here that we've developed a short link, bit.ly/ACCA-OSHA. Make sure you use all lowercase for that so that it works for you, that link. And we'll also be giving all these links at the end. This article does cover how things were extended and some of the background and development of it. And again, there is a handout available for those that are listening live to this webinar. Just click on the orange arrow and it will pop out and you can get a handout of the slides from this webinar. If you're watching a recording of this, just contact TruTech Tools and we can send you a copy of the slides. There's some news and some changes just recently in July. The Air Conditioning Contractors of America lobbied for and received extensive clarification on this confined spaces and construction rule. It does very largely minimize the impact on residential contractors or residential constructions, and therefore, subject to giving you an interpretation, it would extend to those working in the home performance field. The for instance, some of the clarifications that were provided were electrical and mechanical hazards must be in the way of you exiting the space, not just be present in the space. Before that, it wasn't clear if an electrical hazard was present that it would indeed make the space a confined space. Other clarifications include activities outside the attic will rarely make it a permit required confined space. We'll cover the definition of permit required in just a moment. Things like the presence of asbestos does not make it a permit required confined space. And evaluation of a space to determine whether it's permit required or a confined space can be done remotely if adequate knowledge of the space is present. That means someone does not have to go on site if they're conveyed details about the site sufficient for them to be able to determine if it's a permit required confined space. All these details are provided on an OSHA website. That's www.osha.gov/confined spaces, all one word, /FAQ. That means frequently asked questions.html. That page is continually being updated. and you'll see there a lot of plain language question and answers to help you understand how this standard may affect you. So this is where you go for that kind of information and full clarification. However, this doesn't mitigate or remove the need to be careful. No matter what the standards say, no matter who lobbies for what, accidents still happen. So that's one of the reasons why we're doing this, is that there are still situations where people can get injured or even die on a work site due to various conditions. So we feel it's important for everyone to understand those conditions, and whether or not the rule applies to where you work, you should be aware of the rule and the impact it can have on employees. So there's some of the headline articles here about occupational safety and health related issues where there's been deaths and injuries. If you're looking for interpretation and you want to talk to your local regional office, you can find out where that office is. There's a website. Again, we created a short link for you, bit.ly/OSHA off, and that's capital OSHA, lowercase OFF for OSHA offices. You can go to that link, and again, we'll provide a link library at the end of this session and stick on that screen for a moment so you could copy these links down to find out in your state where the local OSHA regional office is, and you can ask the questions that you need to ask to determine how these things impact the work you do. So what is a confined space? There are three mandatory characteristics of a confined space. One is be large enough for a worker to enter it. Even just putting your head in the space, in some of the code languages, like if any part of the body breaks the plane, that kind of wording, if your head just enters the space, you have entered the space. So that's one thing to keep in mind. Your whole body doesn't have to be in there, but a part of your body can be in there. The space must also not be intended for occupancy or regular continuous entry. In those cases, then other codes would be in place, but this is sort of a temporary workspace. It must also be difficult to enter or exit. A structure with an open wall on one side, generally speaking, would not be difficult to enter or exit, but something like a crawl space or an attic could be. Permits that might be required for confined space is one thing to define that it's not a building or a construction permit. The permit is specific to the work site, so it isn't just one thing that can be created once, but it's going to be unique and different for every work site. It's something that's kept on file at your business and at your work site, and basically you've identified that this area needs to have certain procedures and be employed in order to work in that space and stay safe. A permit required confined space, a space that's a confined space that meets those three factors that we mentioned a little bit ago. Just going to go here and look at a question. Okay, they'll get a question about how are all three going to get credit? We covered that a little bit before. Only one credit for one person registered for the session. That's the BPI rules. So it's just one person. A space can be a permit required confined space with the presence of any hazardous or potentially hazardous atmosphere. The potential for engulfment, that means being surrounded by an atmosphere that's not a normal atmosphere for breathing or working in, or potential for suffocation. It also can become permit required if there's a physical hazard, for example, temperature, electricity, oxygen level, flammable materials present. Even animals and insects can be considered physical hazards, and physical characteristics that can create impediments to entry or exit. Things like joist-only floors, converging walls, sloping walls, etc. And one factor is a hot permit does not necessarily mean a thermally hot area. A hot permit means the permit is active and there is an active hazard present. All these factors that are in red on the screen here are ones that we're going to cover and talk about today. The changes in atmospheres, the changes in temperature and oxygen level, those are all the factors we'll be talking about today and focusing on in this session. If a space is a permit required confined space, a pre-entry plan will be required, whether it's a permit required or just a regular confined space, if it's been defined as a confined space. Again, you have to reflect back on the new developments with the interpretations that are on OSHA's website. So this is sort of a moving target. So you need to know if a space is going to be required or not, and that's where you might want to call in to the regional offices. Appropriate entry and exit points should be defined. A ventilation method should be defined in the case that the situation does turn into a situation where there's a hazard present. And basically, bottom line is you want to try to control or eliminate all potential hazards in the space, and that way it's no longer permit required. That means there's no special gear, no watchdog, no person on the outside, no harnesses required, generally speaking, if you've controlled or mitigated all the potential hazards in the space. And again, this is not a blanket statement. It's something that has to be individually analyzed in each situation and for your work too. And we suggest you contact OSHA for that specific guidance. We want to ensure that the air in a confined space is tested for oxygen, flammable substances, and toxic substances. And we're going to talk about and break down those three factors in just a moment. And then if a permit is required, that means a physical hazard is present. Rescue procedures and equipment must be determined in advance. And you should also monitor the space for while it's occupied for changes to make sure you stay in compliance throughout the stage of work. Someone's asking if they listen on the phone, will they get BPI credit? I don't believe you do, because there's some visuals here which are also important to it, to understanding what's going on. I'll try my very best and I'll check on that, but I believe it has to be attendance at the webinar. Just listening on the phone is not allowed. So why would we want to measure temperature or humidity in a space? There's a situation that happens in the body called heat stress, which is an early stage of a more dangerous characteristic or more dangerous bodily process called hyperthermia that can actually turn deadly. You might also have heard it as heat prostration or heat exhaustion, and that's where bodily temperatures maintain levels above 104 degrees Fahrenheit, and this can be life-threatening. Someone's asking if they're going to continue to get credits. I'll look into it. I'm just going to keep on going with the flow of the webinar here. So the body does lose heat through sweating, which anyone involved with HVAC would understand it's a form of evaporative cooling. Therefore, ambient temperature and humidity factor together into heat stress situations. So it's not just the heat, it's the humidity, as the famous saying goes. So wet bulb temperature could be used to give an indicator, but wet bulb globe temperature is actually more important. There are devices to measure that, like this device shown here by X-Tech. It's a tool that takes into account the radiant heat from surfaces, building surfaces, and even exterior things like the sun that would be absorbed and also impact the person and impact the heat stress that's on the body. So there's actually a temperature sensor underneath this black bulb at the top of the device and a humidity sensor in the center silver part of the disc. And those two factors are combined together to give a wet bulb globe temperature, which can then be looked at to see what readings or levels are present of wet bulb globe temperature, which can affect sort of the human condition. But actually, we talked before about this 104 degree bodily temperature. How can you determine that? Well, there actually is a way. There's a product called Hot Dots, which is a patented thermochromatic substance that's placed inside a dot and a sticker that's put on the pulse point that can actually give a more complete story about an individual's heat stress, because the humidity, temperature, wet bulb globe temperature can affect different people in different ways depending upon exertion level, the characteristics of your physical health. So these dots, we sell them for $2 each. They can actually be stuck to the skin and they can be used for a full day. And they turn from gray to yellow when the body's experiencing a heat stress situation. So you can know to get out, and they are fully reversible and they do last for one day. So they can be used to detect whether someone is undergoing heat stress. And it's placed on the edge of the wrist where the bloodstream, the blood flow is close to the skin to give it a good idea of the bodily core temperature. So got some crazy things going on here with the slides, but basically there are situations where oxygen can be decreased to less than 19.5%, and when that happens you can pass out. There also are situations where oxygen in the atmosphere can be increased, and when it's above 22%, it then is a different level of flammability combined with the combustible gases. Things can happen at earlier levels because more oxygen is present. So you want to monitor oxygen basically to avoid the situation where there's too little for you to pass out. There's things like accidental release of refrigerants, which are covered in things like ASHRAE Standard 15, where the refrigerant can actually engulf and displace the oxygen, or in variable refrigerant systems where over a large amount of refrigerant, several 100 pounds of refrigerant can be coursing through a loop and be controlled at different head units, and then accidentally be released into a smaller space and cause a flooding in that space. So there's a lot of situations where this can cause a problem. Why would you want to measure flammable gases? There's something called the lower explosive limit, and that's the level which you want to detect gases to let you know if there's a situation present where an explosive situation can happen. The LEL, or lower explosive limit, is the minimum concentration of air in which a propagation of a flame cannot occur in the presence of an ignition source. So it's the most amount of gas you can have. That's the limit of gas you can have in a normal atmosphere. And again, these are normal atmospheres, which means it's oxygen enriched atmospheres can cause a different situation. Got a question here: when entering a basement and things are visible by looking at an open space, can the head be inside? No, the head cannot be inside. That's correct, because the bodily part has entered the space, like we talked about a couple moments ago. And in terms of seeing asbestos, you'll have to look at those FAQs, but in general, the presence of asbestos will not make it hazardous, would not make it a hazardous space. So the lower explosive limit is illustrated here. And in this situation, you can see where the lower explosive limit is reached for a concentration of gas in normal air. That means air which is 20.9% oxygen approximately. In this situation, it's green. That means you're below the lower explosive limit, which is too lean for combustion, not enough oxygen available for combustion. And then it moves through the red range, where the concentration will support combustion, the concentration of gas in normal air. And then it can move into another range where there's a higher concentration of gas, where it's too rich to support combustion. There's not enough air for the fuel available. That's called the upper explosive limit. Now you notice this is green, red, and yellow. Yellow does not mean safe like green does, because in an area where it's too rich for combustion, you're above the upper explosive limit. The dissipation of the gas, or the introduction of fresh air, can cause it very quickly to drop into a range where it will support combustion, and then it becomes a flammable atmosphere, which you don't want to enter into. And most of the devices you'll see limit the exposure to 10% of the LEL, and that would be for both methane and propane, which is a different concentration of gas because they are different chemical compounds. But it's well below the upper explosive limit, but it's a 10% factor of the lower explosive limit, is where most devices are going to sound off. So why would one want to measure toxic gases like carbon monoxide and hydrogen sulfide? Carbon monoxide poisoning is a big factor. CO is called the silent killer because you cannot detect it with any human senses. It can come from combustion sources, of which there's lots around in all our activities of daily life. It can be introduced into a space through venting issues, and actually be caused by venting issues when the airflow is not correct through a system. And it's often misdiagnosed in the human body because it does mimic flu-like symptoms. It's a poison which is debilitating. It can slow you down. It can knock you out. It affects the absorption of oxygen into your blood. So it's a cumulative poison that builds up over time. And there are even low levels of CO are under study for long-term effects that they have, even though they might not be totally debilitating. There is just the presence of a low level of CO continuously can cause issues. So that's why we're so adamant here at TruTech about measuring CO properly, correctly, and also providing alarms for people to be able to detect it in the living space. The permissible exposure limit on a time-weighted average, because it's a cumulative poison, it's both the concentration level and the time that impacts things. So the PEL is 50 parts per million at 8 hours, and the maximum value over a 15-minute period is 200 parts per million, because that's sort of a spike and that can get into your system very quickly. Hydrogen sulfide is a gas that can be produced from biological sources and can also just be coming from basically from sewage gas, that kind of thing. Most people can detect it with their nose at less than 2 parts per million, but the nose is not a reliable sensor in that the nose will get an olfactory fatigue. It'll just get tired of smelling the same smell and will no longer pick it up in the same concentration, so you cannot rely upon the nose. In carbon monoxide, there's no way of detecting it with the human body. It's not a gas you can detect with your nose or eyes. Respiratory effects of hydrogen sulfide are basically causing like an acid to be made inside your lungs, where the hydrogen sulfide mixes with the 100% humidity and makes sulfuric acid, which can then cause problems inside your lungs and things like fluid buildup and pneumonias. There's a general industry ceiling limit of 20 parts per million, and then the general industry peak limit is 50 parts per million for up to 10 minutes if there's no other exposure during your shift. So there's some fairly low levels here that have to be watched, monitored, and advised for people working in the space. Now, we've been talking about oxygen, carbon monoxide, and hydrogen sulfide up to now. So we did get the question a lot, how do I select a gas monitor? Do I select a single gas or a multi-gas unit? When we look at single gas monitors, there are separate costs to them. There'll be separate maintenance to them. You have the physical size of several devices you have to hold together, multiple displays to read, which one is going off, that kind of issue. More to carry around, more batteries to maintain. So usually when you need to have even a 2-gas monitor, it makes sense to get a multi-gas monitor, especially if you're looking to monitor 3 gases like oxygen, combustibles, and carbon monoxide. If you would want to get a 4-gas unit, usually the 4th gas, and there are multiples available because these are industrial products, but hydrogen sulfide is usually the 4th gas, and usually the basic 3 are O2, carbon monoxide, and combustibles, with hydrogen sulfide being the general choice because of its prevalence in and around our work and our lives. These devices also come with pumps. So why would you consider a pump or a non-pump unit? Well, it boils down to measuring the space before entry. A pump unit will allow you to do that. You won't have to put the device in space. You can put it on the end of you can attach a hose to the pump and a wand, put it into the space, throw a loop of hose into the space, and monitor at a good distance away before you enter the space. If you're going down, across, up, wherever, and check things out before you make entry. So what about the gear that you might have versus the OSHA standard? How do these things compare? You have a combustion analyzer. It has an oxygen and a CO sensor on it. So why couldn't you use it for personal monitoring in a confined space? Well, carbon monoxide analyzers zero out the CO sensor and zero, in quotes, zero out the oxygen sensor to the ambient condition when you power them up. So if there is CO present or an oxygen depletion, the analyzer won't know it because it's referencing to the atmosphere you're powering it up in. So you'd always have to make sure you were referencing it in an area that had no CO and normal oxygen levels. You'd also, because of the way the sensors are embedded in the device, a combustion analyzer, it's purpose built for monitoring flue gas. So you're always going to need to have the pump running and the probe out, checking the area around you with a combustion analyzer. And again, the zeroing might throw off the factor as to being able to detect some of those low levels. On top of that, it does not monitor combustible gases with an LEL output, and it does not monitor hydrogen sulfide in the combustion analyzer. Gas leak detector that you might have probably does not measure LEL, or lower explosive limit. Non-compliant products with this phrase about measuring LEL, the Testo 316-1, the Backrack Leakator 10, or the Leakator Junior by Backrack, none of those actually measure the lower explosive limit. They detect relative changes. But in order to make a measurement, you need a little more refined device, and we'll be talking about those in a moment, some specific brands that we carry. Your personal CO monitor, your ambient CO monitor, things like the SENSIT or the Mercurco, these small devices are purpose-built for personal safety monitoring. They have lights, they have vibrating alarms, they have audible alarms. They're designed to be rugged and used in the field for personal monitoring for CO. Non-compliant products like the Testo 317 and Fluke CO220, non-compliant in the sense that they may not be used as a personal safety monitor. These are stated, like you can see right here, excerpts from the instruction manuals from these two products that state that they're not to be used as a personal safety monitor. They can be used for ambient air detection, but not for personal monitoring. So the bottom line is use the right tool in the right place and use it for the purpose it's designed and built for. Now jumping over to BPI 1200, so we cover this today, section 7.1.1.3 talks about an LEL alarm. When you dilute it down, this is a phrase directly from the standard. The device, the combustible gas leak detector, must be capable of providing a digital display of % LEL or provide an alarm when detecting combustible gas exceeding 10% LEL. So this is part of the new BPI 1200 standard, which is in effect and should be enforced at this point. And again, the LEL for gas, for methane, we talked about it before, and propane, two different levels, small concentrations of gas. You do need a precision sensor to measure this. So basically, if there's no LEL display or alarm at 10% LEL, it's a no-go for BPI 1200. So any device that does not provide LEL display or LEL alarm is a no-go for the BPI 1200 standard. We do have a couple compliant, BPI 1200 compliant combustible gas leak detectors we sell. The one on the left, the HXG2D by SENSIT, made in Valparaiso, Indiana. Great people, great factory. I've worked with them for years. They developed that device specifically for an industrial situation, but it overlays very directly into the BPI 1200 spec. That's available for less than $400. The one on the right, the EXCO plus 1200, covers the OSHA and the BPI 1200 requirements together, and we'll talk about that in a moment. That's really the first dedicated monitor to covering both of those factors. It does do the gas leak detection with the 10% LEL. Now jumping over to product maintenance, there's something called the bump test, which verifies the performance of a gas detector and makes sure the sensors are responding to the target gas. It's sort of like giving an elbow to your buddy sitting next to you to make sure he doesn't doze off during a company meeting. You want to make sure he's awake. You didn't actually take his pulse or take his heart rate or anything like that, or his temperature by the bump. You just bump them and make sure some basic performance is going on. So it does not calibrate the sensors, but it verifies the detection of the gas. Calibration is a different factor that's done generally with a certified container of calibration gas, a regulator to provide the correct flow rate of the gas, and a hose and a fitting such that they fit all together with the product you have. And we provide those calibration. We provide calibration, but we also provide the calibration kits if people are interested in acquiring those to do their own maintenance. Sensors also occasionally need to be replaced. They are usually plug and play. they can be inserted in the device, enter a code, or reboot the device, and it will go back to functioning normally. And you can get from 2 to 5 years, depending upon the type of sensor. Oxygen, usually 2 to 4 year range. The toxic gases like CO and H2S in the 3 to 6 year range, and the combustible sensors in the 2 to 5 year range. So combination tool, we looked at this actually, it was almost a year ago when we saw the two standards kind of converging for the confined space rules from OSHA and the BPI 1200 standard. So we worked closely with SENSIT to create one tool with one mode, one display, all the data, with all the complete accessories for doing confined space entry, flue gas testing, filters for particulates, and NOx gas. Again, that's part of the BPI 1200. You want to filter NOx before you measure CO, and even a carrying case. So we put this whole product kit together with a continuous pump. It's also got the gas leak sensor at the tip of the probe that gives fast reaction. The combustion sensors are buried inside the device, but if you're looking for a quick leak detector, it's done right here at the tip of the probe. So this is sort of a sales pitch, but it's what you want to look for. If you can get a tool that does multiple things, you're usually further ahead. So the specs on this product, it does measure and display the LEL, the oxygen. Again, these are all the things we talked about. ppm CO, it does ppm CO air free for BPI. It does have a proper probe that's required by the standard. It does the 10% LEL. The oxygen, it will give you visual and audible alarms, but when the oxygen drops in and out of the range, and a carbon monoxide alarm. It also stores tests so that they can be used for your BPI evaluations. Got a question here. How large is it? The device, I actually have one here, but it's in a box, and I'm going to say it's about 12 inches tall. Yeah, right around the size of a sheet of paper, 11 or 12 inches tall. Fits very nicely in the hand. We also put together a kit to cover both the BPI and OSHA concerns. That's the device I just mentioned, the combination device. And what's required in BPI 1200 very basically is a combustible gas detector with LEL display, a device that measures CO air free, and a continuous personal monitor. And the BPI has clarified the standard in that the continuous monitor for CO must be on all the time and it can't be part of another device. It has to be a separate device. Things like the OSHA specification, a 3-gas monitor for the 3 basic gases you run into in a hazardous space with a pump so you can do pre-entry evaluation. So we put these two together at a special price to help people kind of overcome these two hurdles at once. So here's our link library. So you can kind of go through if you want to copy down these links or do a screenshot. Again, the handout is a PDF of the slides, which you're looking at here today. So you can actually go through and download that PDF, and you'll have all the links there present. We're moving now into the question phase here. If anyone has any questions about the topic. And we just wanted to mention, if you go to our website, we do have a resources link, and the resources link will take you to our video library, technical training, books and guides, webinars, software, and also free downloads. Things like the combustion applications guide is available there in the free download section. So are there any questions? Okay, I'm going to go ahead and stop the recording at this point just to keep it shorter, but I will stay on to see if anyone else has any questions.